Hi, my name is Brian, and in this video I'll describe the range of things that you can do to build an entry-level electronics lab for the more serious hobbyist. You can start out even simpler than this, but to have the tools to do more serious work, I'd argue that what I have here is closer to an entry point for someone that's doing a bit more than just basic futzing around. So you can get into a bit cheaper, but you can also spend much more. So as an overview, we're looking at modest priced equipment, but for the more serious electronics person. And once again, higher end equipment can be 10 times as much, 100 times as much, even 1,000 times as much, literally. So in this, you're going to need, workspace and table, the test equipment, obviously. You need equipment and parts storage, meter, probes and various leads, wires, cables, adapters and clips, task lighting and flashlights, a sacrificial work surface for soldering, such as this, tools, obviously, adequate mains power, inspection magnifiers for looking at work close up, and you really should have some appreciation for the safety issues that are ever present when you're dealing with electricity. Now, for the test equipment, the most often used item is the lowly handheld digital multimeter, and anyone who's serious about electronics should have at least two decent ones. You don't need high dollar ones, but you need two decent ones because you need to be able to measure current and voltage at the same time. I think the thing that most people think of, the sort of core iconic instrument of an electronics lab, is the DSO, or the oscilloscope. And it's sort of a digital multimeter, but with kind of a more visual presentation of the data. And in my case, I have it kind of front and center and kind of displaying some waveforms there. So the oscilloscope is the sort of iconic core instrument in the lab, even though the most frequently used ones are the handheld digital multimeters. So in addition to that, most of the more serious entry-level electronics labs will also have a bench multimeter, which typically is high resolution and also has 4-wire resistance measurement. This particular one is a 5.5 digit. Many of the folks who are in it in a more serious fashion will have 6.5 digit. Some will have 7.5 digit. Some even 8.5. But you're talking thousands of dollars for that. This is basically entry level, as I said. But you're also going to need power supplies to power your units you're testing, and useful to have several channels, several outputs, and the ability to accurately control both the voltage and current. And a precision bench power supply, such as the Rigel DP832. And this is, again, an entry-level model of a bench power supply, precision bench power supply. But a piece of equipment like this, which ostensibly is just there to provide power, is in some sense actually a piece of test equipment in its own right. Perhaps the least required piece of equipment for someone just getting into it in a more serious fashion, but something that is absolutely necessary for someone who's truly into it in a serious fashion, is a function generator. And you use this to inject signals into test setups, and you need to be able to alter the frequency, the amplitude, duty cycle, wave shape, and in my case, my function generator, arbitrary wave function generator, is in fact my most expensive piece of equipment. So beyond the sort of the core equipment like that, you need stuff to go with it, like meter leads and probes and the clips and various types to connect the equipment up to whatever you're looking at. You need power leads to connect power from the power supply to the device under test. And, for that, you're looking at like banana to banana connectors, banana to alligator, banana to mini gripper, that kind of stuff. When you get onto the board level, you're typically looking at somewhat smaller gauge wires for your signals and such. So you'll use like mini alligator to mini alligator, mini gripper to mini gripper, micro gripper to micro gripper, and the push wires you would see with a prototyping board. And I'll show you that in a second. In addition, if you got a function generator or working with RF, you're going to need BNC adapters and coax cable and the stuff to go from, for example, the function generator to the oscilloscope. So BNC adapters and coax cable obviously necessary if you're going to be using a function generator like this, or if you're going to be working with RF related stuff. I mentioned a prototype board. Let me grab that so you know what I'm talking about. These are the basic boards that pretty much anyone in serious electronics uses to do prototyping of circuits. And you can plug the components in without having to solder them. And these wires are set up so that they plug in, push them in like the components, with again not having to solder them. So an item like this, it's limited in how complex, how large a circuit you can build, and some people will use multiple ones and then they kind of tie them together, or oftentimes you can prototype a section of a circuit or a section of a larger system, and work at it basically a circuit or a system at a time, and then build them together. But for working on this, you're going to be using, for the most part, through-hole components. And nowadays, a lot of people, when they do a more finished product, are going to be using SMD. So what will often happen is people will prototype using something like this, or regular, proto boards with through-hole components, and then when they work out the bugs and get it working correctly, then they'll build the actual device using SMD. Still people who are building through-hole, so I don't think that's going to go away anytime soon. And again, for prototyping purposes, through-hole still exists. Another item of use is temperature measuring devices. You need oftentimes to be able to measure the temperature of a heat sink or component to make sure that you're not pushing it too hard. You need to, sometimes if you're building a larger cabinet or box, you want to make sure that the inside of the box is not getting too hot. So you need various ways of measuring temperature. And in my case, I have the Fluke 80TK thermocouple module, which you plug in the thermocouple, and then you can select Fahrenheit or Celsius as the output. And basically you plug this into a multimeter and select the millivolts range, and the temperature will be displayed basically as the millivolts, whether you select Fahrenheit or Celsius. And I have basically a surface contact type probe and the basic sort of free end TC. They're kind of a bit unwieldy, stiff wire being the norm. So, but again, there's going to be a lot of things that you're going to need to know the temperature of. So having a means of measuring the temperature is obviously important. Other things that are useful to have, calculator. If you're doing RCL work, or working with 555s or anything like that, you're going to need to be able to calculate time constants and the like. So having a calculator is of importance. And sometimes having a timer or a stopwatch, again, very useful. Additional tools, PC, laptop, and the tools on that, being things like KiCad, LT-Spice, mechanical CAD programs, Excel, and stuff to do web browsing and email, that kind of stuff. But another thing that's maybe not respected as much nowadays, but still necessary, is notepads, pen, pencil, scale, ruler, tape measure, the ability to sketch down things quickly, even if you're going to wind up putting it on a computer. The ability to kind of sketch your ideas down quickly on paper, or if you're just taking data down, writing the data down, you're going to need some way to do that, and having a the paper to do that, pen, pencil, scale, ruler, tape measure, notepad, this stuff isn't going away anytime soon. Okay, so now the workspace itself, workbench or table. In my case, I made this out of a sheet of 3/4 inch plywood, 2 foot by 4 foot, and on the edges I sort of doubled up about 1.5 inches deep just to stiffen it up. I can sit on this if I want it, and I want to, but and it looks pretty decent as is. I have this sort of sacrificial board on top to protect it if I'm doing anything like soldering or whatnot. But the table looks pretty decent. It's not furniture, but you need a work surface to do your stuff. And I already kind of mentioned in passing the sacrificial work surface. If you're going to be doing soldering or anything that in the industry they call dirty work, you need a surface to do that work on, and you probably don't want to mess up your table if it's in a nice looking table or otherwise in decent shape. So having a work surface that you don't care about is a useful thing. And what I've done with this is basically just a 1/4 inch sheet of MDF, and on the back side of it I glued a thin kind of rubberized sheet, the kind of stuff they have in like drawer liners and toolboxes or in the kitchens. It just protects the table and keeps this board from sliding around. And if after a month or two this gets kind of nasty looking, and it will if you're doing a lot of soldering or that kind of thing, you just take the sander to it and boom, you've got a new surface, back to normal. This should last years. And if it finally dies, what are you out? A couple of bucks? Make another one. So an additional thing that's you need kind of in your workspace is periodically anyway, an ESD mat with the wrist strap and the grounding system on it. Now, in my case, I have a mat that's about the size of this sacrificial work surface. So the mat, I also have the wrist strap, and here's the ground wire that actually connects everything together, and that's physically grounded at an electrical outlet. Basically what I did is the screw that attaches the cover to the outlet is grounded to the metal frame of the outlet. So by running the wire for the grounding system to that screw, it grounds the system without having to go inside of the outlet. So no safety issues there. And of course the ESD system has like a 1 meg ohm resistance built into it, so you're not technically directly tied to the ground anyway. So an ESD mat with the ground strap and then the system connected to an actual ground is an important thing to have. And in my case in particular, because I'm working in an apartment, and this is carpeted flooring, and carpet and static sensitive electronic devices are not a good combination. So having an ESD mat, maybe not absolutely necessary for some people who like working in an area that doesn't have those static generating things to the same degree. Even still, if you've got a few $100s or more invested in, some pricey RAM or other static sensitive things, do you really want to take the risk of messing them up when a grounding system like that is $20, $30, $40? Take your money, you take your choice. Now, beyond the ESD mat, kind of the last item on the workspace issue is the task lighting. Now, I'll show you later. I have an LED light above this, and actually an adjustable voltage to control the power to it. So that's an important. If you need to have good lighting for working on stuff, and oftentimes, even if you got good lighting, if you've got a device or a box that you need to work on, you might need a flashlight to be able to see inside because you can't get the test lighting down to look at it. So lighting of both the overhead task lighting type and flashlights is important. An additional thing, and this is basic to any kind of shop, whether it's electronics or not, you need tools, hand tools. Screwdrivers, including the kind of smaller jeweler P00 and up screwdrivers, needle nose pliers, diagonal cutters, and I prefer the kind of flush cut diagonal cutters. Stuff like these. I think these are Exolite. No, these are Crescent. So flush cut, and what these are good for is being able to cut real close to the circuit board, or if you're cutting off like the stem or whatever you call it on a tie wrap, you can cut it right up to the nut so that there's nothing sticking out. So flush cut, I think, is the preferred. Having the larger ones for cutting big wire is useful as well, but for most of the components and smaller stuff, flush cut for sure. Wire strippers, obviously. And that's a lot of personal preference in that choice there. So I won't begin to tell you what I think you should use for a stripper. Razor knife, Torx, bits, hex key drivers, tweezers. You wouldn't think you need tweezers, but if you're working SMD in particular, tweezers are essential. So tweezers, don't overlook those. Wrenches of various types, nut drivers. Again, basic hand tools. You can't do much of anything in any kind of lab shop without hand tools. But for electronic stuff, there are very specific tools we use for that, and I'm talking obviously about soldering tools. In my case, I have the Heiko FX 951 solder station, which has various tips. You can change the tips on it. It comes up to temperature quickly. It's temperature controlled, so you can very accurately control the temperature. I like it a great deal. When you're using it, you put it on the iron holder. It goes into sleep mode, so that it's not driving the tip at max temperature the whole time. And in addition, for doing SMD work or other purposes, a hot air gun like this here is very useful. Even if you're not doing hot air, or SMD work, the use as a heat shrink gun is very useful. Now, what I've done with this guy, my hot air gun, and it's a 858D clone, cost about $50, and I don't know that there are any authentic ones. I think they're all clones. But the way this works is the handpiece sits in the cradle, and initially the cradle came from the factory, bolted to the side of the base station. But I didn't really have the space for that, and in its operation, and I'll lift it up here. You can see it's going up to the set point. Right now, the set point's only 175 degrees C. I've been using it for doing some heat shrink tubing, so it's not at the the higher temperature. But you're doing your thing, and then when you're done using it, You put it back into the cradle, and then you'll see the temperature ramps back down again, or basically they shut the element off, but they keep the fan on to cool off the element until it gets down to 100 degrees C, and then they basically shut the fan off as well. So what I did, because I didn't want to be sticking the hot air gun back into the unit inside of the rack and risk a fire situation because of that, I took the cradle and disconnected it from the base station, and then basically remoted it to the outside so that I didn't have to do that. And the advantage here is, you know, I have it in easy access. I can just grab it, no problems about it. And when I'm done, put it in the cradle. It ramps down the temperature, cools it off, and then, you know, the hot air is blowing up and causing no problem at all. So I like the way that arrangement works, and you know, it's out of the way, so it's not impacting my ability to do any work. And you know, in addition to the tools per se, you obviously need, and this is the various solder tips for the Heiko solder station. You need the tools to actually make this work, and that includes various solder fluxes. In my case, I have both 6040 and 6337 eutectic solder, and generally they recommend using the smaller stuff. Certainly when you're working circuit boards, you know, 020 and smaller. So I have 020 for working on the smaller stuff. But if you're doing, you know, 12 gauge wires, soldering into lugs and whatnot, you know, using a somewhat larger size of solder is useful for that. And I have some 031 for that. I wouldn't go any bigger than 031, but having 031 and 020, or perhaps even smaller than 020, probably a good idea. I mostly use the 6337, but I have 6040 as well. And in addition to the solder, and the solder has flux built into it, you also need flux itself to treat the surface beforehand. And you have various types of flux, some stuff from Radio Shack days. This is a flux pen, which is kind of like a magic marker, so you can dispense flux on a circuit board or something like that in a pretty controlled fashion. So that's very useful, but you know, the capacity is kind of limited in that. So for a lot of things, it's useful to have a small bottle like this with this little needle on it. I've got a cap on it, and you can use this to dispense, you know, a controlled amount, in very small quantities as well, of flux onto your component. And something like this is pretty important. I would dare say necessary. So put this away. Okay, so in addition, on the soldering end of the spectrum, if you're going to be doing SMD work, you'll probably need solder paste so that you can do, you know, reflow soldering. Onto inspection tools, and by inspection tools, you know, I'm referring to the tools you use to, you know, inspect to make sure you've done a good job, or otherwise to be able to look at what you're doing. And for that, I'm talking about the good old magnifying glass. You know, I'm getting up near 60 years of age, and my eyes are not 18 years old anymore. So having the ability to see things, you know, I need to wear glasses for one thing, but being able to you know, see things a little closer up with a magnifying glass is, you know, frankly a necessity. And you know, the downside to a magnifying glass like this is, you know, you need to hold it in your hand, so it occupies one of your hands. So to avoid that problem, it's useful to have one of these headband magnifiers. I like this. It's sort of limited magnification. It's only like 2.5 times. Probably be better if it was a little greater, but the depth of field is kind of limited, so you got to be committed to use something like this. But it's useful when you do. Another tool in the inspection area that's very useful is the inspection microscope. Now, this is one of those USB types that has a relatively limited field of view, but you can control that and the magnification by how close or far away you are to the object. You can make it by lifting this up a little bit more greater field of view but less magnification, or bring it down and you're more magnification but smaller field of view. So you can do that, kind of move that way grossly, or you can kind of fine tune it here, and then right here is your kind of focus. So you're able to focus from a pretty large range of distances. So it works out great that way. My major concern before getting this, of course, though, was that was latency, because it does you very little good if you're trying to use this while you're like soldering, for example. If the video is coming in a half a second or more after you're doing it, you can't coordinate what you're doing if the video is delayed that much. So latency was a major concern before getting this, but fortunately the latency is pretty darn small. It's pretty close to real time. So I haven't done a whole lot of soldering using this yet. I've only had it a short time, but it is useful for that, and because the latency is small and you can control the magnification field of view by moving it up and down and focusing it, it's very useful. Oftentimes, again, with older eyes, or if your eyesight isn't good for other reasons, it's tough to see the numbers, the lettering on these very tiny chips, particularly the SMD stuff. So having the ability to use this to get a close look at it, take pictures of it, in fact, take video of it, in fact, very useful. So that's useful. And sort of the last item on the inspection thing, and this is more like the traditional helping hands kind of unit. So you've got the alligator clip so you can hold your wires or components or whatnot, and a magnifier above it to sort of help, and you don't have to hold it, so it's convenient in that sense. But it's a limited size, and you have a very limited workspace, so it has its limitations. It's okay for what it does, but it has its limitations. All right, so onwards. Storage, huge issue. You've got lots of different types of things to store. I have what I'm first of all refer to as equipment storage. For things like meter leads and probes, power cables and wires, signal wires, clips, coax cables, BNC adapters, scope probes. The equipment related storage items. And then the next item on that list is what I refer to as close part storage. It's the components, the resistors, inductors, the capacitors, the kinds of things that you kind of be using on a daily basis that you want close. So I have those up in these two cabinets here, and these are Acro Mills cabinets, if I remember correctly. I'll have links in the show more section of the video, so you'll see that later on. But in any case, on the left-hand side, I have an Acro Mills box cabinet with 64 bins, all of the same size, and it's mostly for resistors, capacitors, the smaller ones, diodes, LEDs, for board level LEDs, that kind of stuff. And on the right-hand side, I have another Acro Mills box. This is like 44 bins, so the upper 32 are the same size as the other cabinet, and then the lower 12 are, obviously considerably larger bins for holding larger things or higher quantities of the stuff. And this is mostly the sort of connectors, the cabling pins. I also have components in there, larger capacitors that couldn't fit in the bins on the other side. Also transistors, voltage regulators, some of the ICs, that kind of stuff. So close part storage. In addition, and I'll show you, I'll bring the camera around and you'll see a little closer on in a little bit. But you need sort of what I refer to as bulk storage. The kinds of storage areas and bins that tend to be larger, and to hold things that are bigger than you can put in these cabinets, and to hold the sort of larger quantities of stuff that you can't stuff into these bins. So for bulk storage, that's an important thing to have. Now, for me, the boxes that I've been using, and I really, really like these, and I'll again have links showing you about them. I have basically 3 different boxes that you can see up here, beyond the cabinets, obviously. I have this very small one, and it has the locking tops, and the tops only have these O-ring seals. Not that the O-ring seals are absolutely necessary, but it's nice to have. And the seals, the clips that lock them in place, they're easy to activate. You don't have to force and then jar it to open it up. So they're very convenient. The efficiency of the space is pretty good. You don't waste an enormous amount of linear dimension to get volume storage. You waste some with the overhang, unavoidable, but at least it's more efficient than a lot of the ones I've seen. So, and I use the smaller ones for obviously the smaller stuff. As an example, my BNC adapters. Now, these are small items, and you could put all of these in a bigger box, but if you've got a big box with a lot of crap in it, then you got to kind of fish around to find what you're looking for. So by putting them in smaller boxes, you're not going to put so much stuff in it. So it's it's easier to find stuff because there isn't so much stuff in it to sort around through. And even at that, the BNC components are pretty small, so even in these small boxes you can put quite a bit of stuff. So what I've done is broken it down still further, and I have BNC adapters and BNC splitters. So the smaller boxes are convenient for these little items, and as you'll see going forward here, I like to be able to break things up in a logical way so that you can get them quickly. So that's the smallest box, this guy here. The next size up, and this one's really useful. You can put meter leads and cabling and lots of different stuff in there, and you'll see them. I have them here and over there. So this is the medium size one, and again, same style of lids and closures, and very useful. And then this is the largest size bin that I'm using here, not counting the bulk storage obviously, but this is again useful for the larger stuff or the things you don't want to coil up too tightly. As an example, my scope probes. So one box has all my scope probes in it, and only scope probes. So the advantage to this type of arrangement is, bang, I've got my scope probe, done. And you know what? I didn't have to untangle it from other stuff. So, and then you're done. A little bit of coiling it back up, back in the box, lid back on, and done. So the larger boxes are good for that kind of stuff, and I have them in a number of other places. So again, I'll have links to indicate where I got these and what they are. So I believe they're made in New Zealand. It's the Sistema brand Clip It series boxes. Really, really good. So next item is power. Pretty important. And you need an adequate supply of mains power to power all your equipment, tools, power supplies, lighting, and the like. Now, my personal take on it is I like to break that up into two different circuits. Noisy stuff on one circuit and the other stuff on another. And so what I've done, for example, is my soldering stations and lighting and other things that have, switch mode power supplies or things that are on the noisy side of the spectrum, I power that from one power strip. And the other stuff, like the oscilloscope, multimeter, and function generator, that kind of stuff, which don't generate that kind of noise and prefer to have a cleaner power source to begin with, I power that from a separate system that only the cleaner stuff gets connected to that. And ideally, if you have the option, and most people probably don't, if you can plug those strips into different outlets on different circuits, that's ideal. The further away you can separate them, the better. But just running different power strips is an advantage by itself. So down the road, you might consider an isolation transformer for powering some units, so that you don't have to worry about ground loops and other things that could introduce some problems. I'm not going to go into detail on that. That's a whole other shebang by itself. But that's something to consider down the road. Additional power-related things, and some people probably don't think about it that often, is batteries. I mean, the good old 9-volt AA, AAA, 18650 batteries. You can use this to power circuits. You can use it obviously in your test arrangements. Even if you're using a bench power supply to provide some of the power, you can still use batteries to provide additional sources of power for the circuits under test. And then ultimately, if you've got something that you're going to be putting out in the field, oftentimes they're going to be battery powered anyway. So you need batteries, but you also need the ability to connect the batteries to your circuit. So the batteries by themselves are not all that useful. You need the battery holders as well. Stuff like, well, for example, here I have a AA nickel metal hydride battery that I'm charging up, and it's in one of those holders. Okay, so with the holders, you've got the wires coming out of it, and then you can use the micro gripper, as I have there, to connect that up to power, and I'm powering it from the power supply, actually charging that at the moment. So bottom line is, in addition to having bench power supplies, batteries are another power source for your circuits, both for testing and for in the field once you're done. And now on to a subject you probably don't hear very often in hobbyist videos relating to electronics, and that's safety. If you're working in the industry, it's not an option. You have to go through various classes. It's not an option in the industry. But basically, for us, what you really kind of need to know is to have a specific knowledge of what you're doing. What you're doing at that moment, and what the risks are in doing it. Having an idea in sort of the sequence of how you're doing it, and again, the risks associated with doing them. And if you get into problems, how you deal with it. The other item is fire extinguishers, because we're dealing with energy, electrical energy, but it's energy, and you can easily cause a fire with power supply with a battery. So you should have a fire extinguisher, and the three basic types that consumers would tend to have. The Class A, which is for ordinary combustible materials like wood and paper. Class B for flammable materials like gasoline, grease, and oil. And the Class C for electrical equipment. And then probably the one that's most useful for us would be the class ABC, which basically covers all the bases. Having a list of emergency phone numbers, and possibly, your relatives or whatever, but having a list of numbers in case you get into a trouble, that you're not at that moment, in that minute of panic, looking for stuff. You need to have it handy. Having a basic first aid kit for minor nicks and cuts is also important. Probably should have one in your house anyway, but if you're working with diagonal cutters or X-Acto knives or razor blades, sooner or later you're going to cut yourself if you haven't already cut yourself. So having a basic first aid kit for the minor stuff, probably a good idea to have. Anything more serious than minor stuff, then maybe going to the hospital or visiting your doctor or clinic is a good idea. But for minor stuff, having a basic first aid kit. I mentioned this before, and it's just kind of reiterating it. Having a plan. In industry, the plan is a formal thing. I mean, it's something you have to write down and submit it and get it approved. So you have to plan out everything you do. Now, at the home hobbyist level, we're not going to be that anally retentive. But still, having at least thought about what you're going to be doing and kind of laid out in your mind the kinds of things that could go wrong, that's an important thing. So that's kind of what they refer to as a plan. Now, there are situations, or can be anyway, where you're working on very high voltage and or high current, and that's an extremely dangerous situation, and particularly when it's energized. And in a situation like that, it's a good idea to have another person around that can respond if you get into trouble. It's difficult to arrange this if you're working on something at 1:30 in the morning. Who do you have on speed dial to come over to help you out? It's something that in industry, it's not a debatable point. You have a second person, done. I mean, it's not an arguable point. And further going on the industry, and we'll just tie that in a little bit more. Pretty much any technician or engineer that works in the high-tech industries, semiconductor industry, for example, you need to have a current OSHA 10 certification or greater. OSHA 10 is a minimum. And in many places, Global Foundries, Intel, places like that, they're not going to let you touch anything as a technician or engineer without OSHA 10. They're also often going to require additional on-site training that site is specifically does. But at the very minimum, you need a generalized safety training, and OSHA 10 is the one that's generally used. So, again, it's not something that we as home hobbyists are required to do, but I think it's probably a good idea, even for the average Joe. You do it online. It's going to cost $60, $70, whatever it is, but and maybe only a third or a little bit more than that is related to electrical work or electrical hazards. But the stuff that you learn related to electrical hazards is important, and the stuff that isn't electrical related, it's useful to know the other things as well. So I would recommend, it's obviously not a requirement, but I would recommend taking the online OSHA 10 course, and it's 10 hours. It more typically takes closer to 15 hours to actually complete. But again, not required, but highly recommended. The next level, as I said, this lab is more of an entry-level setup, though a pretty decent one. And as mentioned, you can spend way more for an electronics lab, and some people do. And if you want to see just how far some people go, take a look at YouTuber Mr. Carlson's lab. You can see the links below. I don't know. I mean, I have to guess that if he had purchased all of the equipment that he has in his lab new, it would have to exceed well over $250,000. I'm guessing that he's picked up a lot of the stuff secondhand and refurbished it. So I'm sure he hasn't shelled out, new money for all of that stuff. But even so, I can't imagine he's got less than $100K of his own money in his lab. I'm not making fun of Mr. Carlson. I don't think it's wise to annoy the second coming of Nikola Tesla and wind up with a wireless lightning bolt fired up my ass. Ain't nobody got time for that. So, in the show more section of the video, I'll have links to the various items, the components, the storage boxes, acromills boxes, test equipment, the various stuff that went into this lab here. And I'm not suggesting this is the be-all and end-all. And, there's different people have different views on things. So what works for me might not work for you, but hopefully the ideas I'm showing here will be of some value to you. So after this, what I'll do is I'll pick up the camera and do a kind of a walk around a little closer up, so you can see the components and the setup a little closer up. Okay, so here's the leftmost storage box, and again that's mostly the resistors and smaller capacitors, diodes, that kind of stuff. And then over here on the right hand acromills box cabinet, I have connectors, board headers, fuses, sockets, pins, voltage regulators, timers, op amps, some logic, switches, that kind of stuff. And in the middle I have the temperature modules, TCs, and some coax cables, BNC stuff. Down here I have the, let me adjust my position here a little bit. I have the solder station and a hot air gun, and the solder and batteries and stuff that go with the replaceable tips for the soldering station. Maybe a little closer up, take a look at the way I have the hot air gun work. If I lift it up, see the temperature going up. Oops, see the temperature going up there, and the unit comes on, and so it's blowing hot air, in this case 175 degrees. When I put it back into the cradle, watch what happens. The temperature goes down, and then when it gets down to 100 degrees, listen, it shuts off the fan. So basically it ramps the temperature down. What happens is there's a magnet in the cradle unit, and inside the handpiece is a reed switch, so that when you put the handpiece into the cradle, the magnet activates the reed switch, and the base unit knows to then turn off the heating element, and then when the temperature gets down to 100 degrees C, it shuts off the fan. So in any case, that's my solder station up here with the remoted hot air cradle arrangement. I have a Tech Power TP3005T single channel, single output power supply. It's 30 volts, it's actually like 32 volts, and 5 amps, which is actually like 5.3 amps or something like that. But it's a single voltage or single output power supply, and it's okay, nothing special, but it's okay. Next over, I've got the Rigel DG1062Z arbitrary wave function generator, and it's 60 megahertz, and it does a good job. It's my most expensive piece of equipment, and again, maybe not the most important piece for someone who's sort of just starting out. And of course above that I got the larger plastic box with the scope probes in it. Over here, let me adjust my position some more. Over here I've got the oscilloscope. Adjust positions to get the glare off of it. Okay, so there's the oscilloscope, and basically I've got the function generator outputting a waveform and sweeping the frequency just to have something to display on there. Oscilloscopes are sort of the iconic focus of electronics labs, even though it's probably not the most commonly used piece of equipment in the lab. And then above that I have storage for the various typically more board level connectors, you know, the mini gripper to mini gripper, micro gripper to micro gripper, and the micro gripper to micro gripper ones. These are the really tiny ones that, you know, you're not going to use to transfer any appreciable amount of power, but are really used to connect signals on boards. You know, the BNC connector adapters and splitters and whatnot are here. Banana to mini gripper, which you can use to put power onto a component. Typically a little bit less power than, you know, less current than some of the other cables you'll see in a moment. Similarly, the banana to mini alligator, again, smaller wire, but the ability to output power, connected up from a power supply to the device under test. And the two multimeters. I have a 25-year-old Fluke 85 multimeter. It's actually maybe a little older than 25 years. And below that is the Fluke 27, which is more than 30 years old. And I've owned both of them since brand new. Okay, so let's move over a little bit more. Now we've got the upper section of this cabinet is, I've got the meter leads. These are basically miscellaneous meter leads, you know, from various meters that have come and gone over the years, and then I've got leads left over. So these are not sort of component specific meter leads, but, you know, stuff that just kind of I had. I have the specific meter leads for the Rigol multimeter, specific meter leads for some of the Fluke meters. I have these mini alligator to mini alligator, which is again sort of board level interconnects. Down lower, I've got the meter leads from Probe Master. That's actually the meter leads that I'm using right now, and I'll go over that in a moment. So, meter leads from Probe Master. The higher power, higher current power distribution cables that I have are the banana to alligator and banana to banana cables. So they're heavier gauge, able to transfer, you know, quite a bit more power than those smaller cables, and they plug in directly to the banana terminals of the power supplies, and then you can use those to connect up to your device under test. And then, you know, finally I've got the last two components, which is the Rigol DM3058 5.5 digit multimeter. It's a you know, a bench multimeter, pretty much the lowest end of the spectrum for bench multimeters. A lot of the guys spend probably double the money for a bench multimeter. So this is definitely at the bottom end of the spectrum, but it's not bad. You know, 5.5 digits is better than anything I got otherwise, and it has the 4-wire resistance measurement capabilities. I've got the Probe Master probes plugged into that currently, and I'm just basically using that to confirm the voltage coming out of the power supply, but actually that's off right now. Okay, and then the last component is the Rigol DP832 bench power supply. It's a 3-channel, 3-output power supply, 30 volt, 3 amp, 30 volt, 3 amp, 5 volt, 3 amp. So what's good about this is it's a programmable supply, and you can set the current and the voltage. And what's useful about that is you can set the maximum current, so that it will not go above that value, and you can set the maximum voltage so it won't go above that value. So when you're charging a battery, for example, I have the voltage in this for this battery set to 1.5 volts and the current set to 100 milliamps. So the voltage is, it's currently under charge. The voltage is less than the voltage set point. So it's charging, but it's charging at the maximum current that I've set it at 100 milliamps. It's actually showing 99. But if I increase that, so let's say 200 milliamp, so now it just increased the current, but the voltage is still less than the 1.5. And over here it says CC for constant current. When the voltage gets to 1.5 volts, it will switch to CV, or constant voltage, and then the current will begin to ramp down as the battery continues charging, and at some point, either the current will shut off or get very, very low, but typically you'll shut it off before then. So that's the components. And just one last thing on these. Obviously I've got mostly Rigol equipment, and the reason for that is Rigol pretty much owns the show for quality entry-level components. You can get a lot better components, but you're going to spend a lot more for them. So at the lower end of the cost spectrum, Rigol is about as good as you're going to get for price performance point. One of the things that Rigol has kind of been gigged for on the online forums and videos when they review the equipment are these bumpers. They kind of say they're doofy looking or whatever, but I think they're great. They're there for a purpose. They're there to protect the equipment from being damaged, keeps the sides from being scratched, the top from being scratched, protects the front panel, the back of it. It's there to protect the instrument. But I think its most important function is that it provides a minimum air gap on the sides of the components so that you can't push this up flush against a vertical surface, because these instruments are cooled by inlets. The cooling air comes in from the sides. There's a fan at the back that pulls the warm air out of the case, but the air goes in on the sides. So if you didn't have these bumpers and you were able to push the instrument up against the vertical surface, you could block off the air from getting inside. So having these bumpers prevents that from happening. You are guaranteed a minimum, it looks to be about 15 millimeters, give or take, clearance. So, and that's on both sides, obviously, and top and bottom. In addition, you've got sort of rubber mechanical vibration isolation with these the bottom sides of it. So, I think it's frankly, I think the design is brilliant. So they have this kind of design on the power supply, and it's very similar on the function generator. A somewhat different kind of bumper arrangement on the multimeter, but kind of designed to accomplish the same thing. One of the problems I had with these components initially was that you would push them, push the buttons or plug them in, and they're kind of light and they would slide around, and it's kind of a pain in the neck. So what I did was on the oscilloscope, for example, and I'll have to push this back so you can see it, I made this piece of MDF actually, that's basically measured to engage the feet of the oscilloscope, so that when the oscilloscope is in place, it sort of locks into, and I'm kind of doing this one-handed, so it's a bit, let me put this down. Okay, so when it's in place, that locks the feet in place so it can't slide around on you, and so that pretty much solved the problem. I didn't really have that problem with the function generator because the metal bands I used to kind of tie the rack together kind of locks it from going back. It's a little further recessed than I would think would be perfect, maybe 10-15 millimeters or so, but it's not moving any place, and I make sure that the bumper is engaging the vertical surface so it maintains that air gap clearance. So I'm not going to worry about it. I did have some problems with this Tech power supply sliding around on me. Not so much because it's light, though it is kind of light, but because the feet are kind of hard and slippery. So, you would press the buttons, or really when you were plugging in the cables, it would slide around on you. So I did something similar as I did with the oscilloscope by putting measuring up something to engage the back feet of the power supply and then gluing that down to the surface. So now this doesn't budge, and it maintains the proper gap. It's not sliding side to side. That works out great. Over here, the DP832 is too heavy to worry about sliding around, so I never had any problems with that. It's heavy enough. The power supply, actually the transformer is heavy enough that it's not going to slide around. But the bench multimeter, that was kind of sliding around. It's a little bit light, and sitting on top of the power supply as it is, it was kind of sliding around. So what I did with that, and you can kind of see underneath it, I have this kind of painted 1/4-inch MDF and then that's connected to a wooden block further back, and basically that wooden block engages the upper back feet of the power supply, and then engages the back of the multimeter so that it can't slide backwards on you, and then this board that comes forward locks it from going side to side, so it maintains alignment, vertical and side-to-side alignment with the multimeter, the power supply, prevents it from going back. And when I'm plugging in the cables and whatnot, it's protected from that. The only place where it's a little bit of a problem is pulling the connectors out, and for that, it's a minor inconvenience, but otherwise, that locks it in place, so we're good to go. And now, let me step over here, and we'll look at the bulk storage area I mentioned earlier. So I have my box with the dip tubes, which is the dual inline packages of various ICs and whatnot. So I have that there. I have miscellaneous electrical parts and I guess LED strips and other stuff in here, some tape and Velcro and tie wraps, that kind of stuff in here, wire, miscellaneous parts, and that includes older projects that I've done, some spare cables and the like. Back here I've got some old oscilloscope probes. That's going back to the Tech 222 and older. And I've got some LAN cables. So, find storage where you can. Then down lower, next shelf down lower, I've got my very first oscilloscope, the Tech 222. And yes, the batteries are dead. But I can plug it in and it still works, so I still keep that. Beside that, I have a good old Radio Shack sound pressure meter, sound level meter, and another Radio Shack amp probe. You got the inspection tools, the helping hands, and the inspection microscope, and then the basic hand tools, okay? Including tweezers and, the hand tools. And then the next shelf down, I've got some additional storage, of, tie wraps, some cable anchors, sticky backs, some like epoxy and glue and, the chemical type stuff, tape. And I've got, hardware like nuts and bolts, screws, that kind of thing. And I've got some of the spare empty boxes that I haven't used just yet. So, again, final bit of the storage. And then over here I've got some drone batteries. And these are DJI TB48 batteries, which are 6S, 6-cell lithium-ion batteries. 129 watt hours, and these are very useful for the drone, obviously, but they're also a really good size to power my LED light panel. That battery, that single battery, can power that light panel from just under an hour at, basically full brightness to 2-3 hours at lower setting. At the setting I've got it right now, I can go for 2.5 hours, thereabouts. So it's just the right capacity, and as you can see the light blinking on it, that tells me what the capacity is. So I'm not quite full. If it was full, it would be the 4 LEDs, the 4 green LEDs on. But, I'm pretty close to that. So that's been on all this video. So batteries are really good. Other things I got here, I've got an old ATX power supply, which is, you can use that for providing additional power for various circuits. And I have an application I'll be using that for shortly. And guess what these are? Guess what those are? Those are dead Tech 222 batteries. They're both dead. Yes, they're both dead. I may make something to fix that at some point. So just kind of over here, completing the review of my lab. There's my desktop computer. I have laptops, obviously, but my desktop computer, which I built this year in January, I have a 32-inch 4K display, 32 4K display, and the CPU box itself. It's like an Intel 5820K processor, an Asus motherboard, 32 gigs of RAM. I've got a 512 gigabyte Samsung 950 Pro PCIe SSD. And because I do a lot of video work, a lot of image work, I've got 2 high-capacity hard drives, both of them 6 terabytes, Western Digital Black. So that's my main storage, and for software and main OS and scratch disk and whatnot, the 512 gigabyte PCIe SSD is there, and that's super fast. That's like 2.4 gigabytes per second read speed, and 1.4 gigabytes per second read speed, or write speed. A little dyslexia going on there. So that's much higher performance than basically any SATA-based SSD. All right, so one last trip around the lab. So, I actually have one thing I didn't mention, and that was the task lighting. So let me kind of tip up there. So I actually built this light myself. So it's a LED strip lighting, 3 750 millimeter strips of some pretty decent LED lighting. It's like 4,500 degree Kelvin lights, which is just about the right for working in a space like this. And so that's 2.25 meters total. And I power that. Basically, the primary power is this cheapy laptop power supply that I got from Amazon. And the output of that, which is like 19 volts, goes into this box here where I've got a buck converter. And then, I remoted the potentiometer to control the voltage up to 12.5, which at the LED itself is like 12.2. The voltage drop in the wires going to it. But I can dim that down to basically where it goes off. The minimum is like 6.1. The LEDs are off at that point, but that's the range, and then power on and off. So I built that not that long ago. I've got a 40 millimeter fan in there to cool things off. It's got some diodes in series with it to slow it down, and is virtually silent. So didn't really need the fan. The buck converter wasn't getting hot enough, but just for general principles and to add a margin of safety, I threw the fan in there, and it works just fine. So that's the lab as I have it set up at this point. And it's not a requirement that you duplicate what I've done, and we have personal taste about the way we do things, and at this point you might not want to spend the kind of money that you need to spend for something like this. As a bare minimum, you're going to need to spend the money to buy at least a couple of decent multimeters. That's kind of the very, very most basic starting point. And you need 2 as a minimum so that you can read current and voltage at the same time. And you can get them for $50, $100 each, and you're good to go at the very most basic sense. But if you're going to do anything more serious than that, you're going to need a kit, something along the lines of this. And I think the capital cost of the equipment, not counting the meters, which are old, but the Rigel instruments, is like $2.5K or maybe a little bit less than that. And with all the other stuff, the storage boxes and whatnot, we're probably talking $3,500, $4,000, maybe a bit more. So it's not inexpensive, but it's not ridiculously expensive either. So hobbies aren't necessarily cheap. Try photography. Try photography. Like that single lens, couple of K. Camera bodies, 3K plus each. Yeah, hobbies can be expensive. Okay, so that pretty much covers the video, and hope this gives you some ideas, from a component standpoint, a layout standpoint, the materials standpoint. I hand built the rack itself, the black wooden rack, but hopefully give you some ideas, and maybe you can thumbs up the video and subscribe, and I hope you get to build your lab and have some fun with it. So thanks for watching.